talking about two-way tables, also known as contingency tables. I like to just refer to them as two-way tables, and if you do as well, that's perfectly fine. And these two-way tables refer to categorical data for two variables. All right, and this part of two variables is important because it just, all it means is that we are collecting two categorical data pieces of information. Okay. Hey, there, Armani got the right one. There, Armani's being let in. All right. So, in yesterday's class, or not yesterday's, well, was it yesterday? Yeah, in yesterday's class, or in the previous class, we talked this idea about vision, right? And for vision, we had some options of wearing glasses, wearing contacts, wearing neither. And we had, oh, so I guess that should be like that. And then we had frequency, and we had 12, 1, and 9. Okay. Now, that's the first variable. So that's the first variable, the information we collected before. Let's collect another piece of information, and that information is gender. Okay, and we're going to talk about frequency. And for the purposes of statistics, it's important, for gender. I know I do want to acknowledge in terms of, gender fluidity and so forth. But, for the purposes of collecting the data, we'll classify in terms of identification, male or female. And, I'm just going to do a ballpark number of what I'm saying, because I don't, some of you don't even have photos, and I don't even know, hopefully I know who's male and female within this class. But it could be a little bit tough. But just going over, like I see about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I want to say 14. And for our purposes, we're going to use that. The total and I know we have actually more students. We have 23 students in here. Actually, we're going to have 24, but we're going to keep this number with 22 as before. So for females, we have 14, and because the total still, we'll use the same count as before. For males, how many males does there have to be based on there being 22 students in class? I know there's 24 here today, but based on this, how many males would be in this collection data? 8. So what I've done is I've shown you in table form as a frequency table each variable by its own. But now what we're going to do today is we're going to combine them. We're going to combine into one table. Okay. Now, so what I'm going to have here is I'm going to put vision on top. All right, so it's going to look like this. And I'm going to put gender over on this side. And my genders, there's 2 genders, so there's female and male. And my visions, there was glasses, contacts, and neither. Okay. And what I'm going to do is I'm going to extend these lines past over here. Okay. We can show that same information on top by adding an extra row called totals. Okay, totals on this, and there's totals there, and there's totals here. Okay, these are what we refer to as column totals. All right, so that's the column totals. We refer to here, oh, sorry, actually I got them backwards, sorry. Those are row totals. And these are column totals. Both of these column totals and row turtles, I like turtles. We also can refer to these as a marginal distribution. And we can refer to this as a marginal distribution. Now, in the column totals, we would refer to this as these values that go here, here, and here. We would refer to these as the marginal distribution of what variable? What is the variable that we're working with? Marginal distribution of what is the data that we're talking about there? Column wise. I think I've heard it. What is it? No, it's actually, well, so opposite. It's, if you go down, it's going to be, it's actually vision. Because it's this total, this first one here is for glasses, contacts, and neither, and they all refer to vision. So we would call this the marginal distribution of vision. So the column totals are the marginal distribution of vision. The row totals would be the marginal distribution of what? Now that's gender, yes. And finally, and actually I wanted to do that in a different color. Well, I'll just do it right here. And finally, we have this last spot right over here. And we call that number, right, or we call that value the total. It's not really for sure, you know, it's not, we're not going to really need to know the row total, column total part. Don't worry too much about that. But what is the total? So that you know where I'm referring to. What number is that? How many students? 22. Perfect. Is my volume down? Oh, my volume is down, that's why. So this is 22. Okay. How many students wear glasses? What number goes here? How many students wear glasses?
12.
Perfect. How many students wear contacts?
1.
How many students wear neither?
9.
How many females within the class?
8. 14.
14. Yes.
Yes.
And how many males?
8.
All right. So that information is all on the side. So if I just want to ask about one single variable, gender, I always look at what's called the marginal distributions. So I'm looking at those side columns, either the row totals or the column totals. Now I could have, if I gave you the option to build this, you might have put vision on the left and gender on the top. In that case, the row totals and column totals flip in terms of what they represent. The row total in that case would have represented vision, marginal distribution of vision, and the other side for gender. There's not, unless I specifically write you like a table and I say do gender here, do vision there. It is not. Typically, I like to do gender on the left-hand side just because there's typically only 2 choices. I like to, whatever has the least choices, I like to put on the row, but there's no right or wrong. You're not being technically graded on filling in the tables or drawing the tables. You're going to be asked to ask them. about what interpreting. Most everything that we do is about interpreting. So if I gave you, and I notice that I have not filled in the rest, okay? Notice that I have not filled in the rest, and that's purposeful, okay? My first question here, I'm going to do an example. Describe the marginal distribution of gender. Okay, now notice we're only looking at this table. Don't ignore it. Yes, I drew that. Ignore it. I want you to look only at this table. This two-way table. Looking at this two-way table, I want somebody, can somebody describe the marginal? Now, you're looking like, wait a minute, is that different than describe the distribution? And the answer is no. The only reason that we write marginal is that I only want you to talk about gender. So marginal typically refers to ignore the other one. We don't care about vision. I do not care about vision. I just want you to talk to me about gender. So I could have just said, describe the distribution of gender. All right. So sometimes what I'm trying to point out here is I sometimes don't even need to write this word marginal, but if you see the word marginal, typically it just means just one variable. You are presented with two variables, but I'm only asking about one. So can somebody, based on what we did yesterday, answer this? And even if you look at your yesterday's homework, it'll look nearly identical.
Is the variable male or female?
No, the variable is gender.
Oh, okay.
I'll start you off. The. Here, I even start you off more. The marginal distribution. And can I get someone to finish? The marginal distribution of, what am I being asked?
Vision.
Of gender. Boom, you just hit one of the points. You just gained a point on the exam. You said the marginal distribution of gender. You identified the variable. That's 1 point out of 3. All right, that's the what. Remember, always need to talk about the who and the what. So we identified the what. We could have also started this person and started by talking about the who of the, we could have started it that way. Either one's fine. So what's my next part for the who?
Male or female?
That's not the who. Who are we asking? Who is this information collected from?
The students. AP.
More specifically?
AP stats.
More specifically?
Males and females.
No, more specifically.
22.
There we go. 22 AP Stat students. So it is the AP Stat students, correct, but we have to make sure we're talking about 22. And that's a very important because we need to know how many students that we are talking about inside here. Is now, okay, we got the who, we got the what. Now we need to just talk about the distribution. Now, and I know some of you have been very antsy about this. Now we talk about males and females. Is what?
Male or female?
Okay, so what are they though? How many? Tell me the distribution. Break distribution just tells me like break it down.
14 females and 8 males.
Boom. Done. Full credit. Perfect answer. If you didn't write the word marginal, you've been fine, but since it asked me to find the marginal distribution, I wrote that. Okay.
So gender is the who and the 22 AP students is the what?
No, the 22 AP Stat students is the who. The gender is the what.
Okay.
The females, males is the breakdown of the what. So when I ask you about distribution, so distribution really just says distribution equals the breakdown of the what. So the what was gender. The who was the 22 students, AP Stat students. And the distribution part was the breakdown of the gender, which is 14 females and 8 males. Okay? Let's go. I'm going to read now. I'm going to read you. Oh, I thought I copied it. Copy. Paste. Okay, so I have this picture again. I'm gonna go and I just want to do it on a separate line for my notes purposes. If you want to redraw this, you can do that as well. All right, so now I haven't been able to collect this information, but I'm gonna almost make an assumption here. I'm gonna put in numbers in here. Now I would have collected this information for you, and it totally might not be true for this class. I have to figure out a better way that during class we can collect information. I think that what I'm going to do is that's maybe part of your homework. I'm going to have people answer a poll question, and then we can collect data that way, and then I can use that data for class. But let's say that this is 8, and let's say that there are. So what does that 8 mean right there? First off, what does that number 8 mean? So the question that I'm asking is, if I put an 8 right there, what does this mean?
Gender?
Mm,
Girls with glasses.
okay.
And the 8 represents the boys in the AP class.
No, actually, it was we just heard it correctly. So I didn't mean to. I wasn't trying to shut that one down. Of the AP Stat students, of the 22. So, I mean, I don't even need to write that right now. It means there are 8 females who wear glasses. Another way of saying that is there are 8 females and glasses. So sometimes we say the and. So when I say who wear glasses, there are 8 females who wear glasses. They're basically the same thing. There are 8 females who wear glasses. Okay. How many males wear glasses?
4.
Has to be 4. The math has to add up. So that has to be 4.
Plus 4 now.
Because 8 plus 4 is 12. And I'm going to fill in the rest of them. Just let's say that this was 1. So that means there would have to be 0 here. Let's go. All right, and
That's 4 in the end.
it has to be 4 right here. Good.
And so that's
Oh.
6. That's 6.
No.
That's no. Sorry, that's 5. 5.
It has to be 5. So
5. So the 1 plus 2. That's 6 as well.
yeah, so everything must add up. Remember, I called them row totals and column totals. So everything still must add up. So the columns, the rows need to add up to 14 and 8. The columns need to add up to 12, 1, and 9. The marginal distributions must add up to 22. So why is that helpful? Well, now I can ask you a trickier question. All right. So here, I'll write this down. When presented with a two-way table, but only want to break down one of the variables in terms of the other. This is what we refer to as a conditional distribution. I want you to break down, all right? So, example. Describe the conditional distribution of gender for the males. Oh, that doesn't work. For glass wearers. Okay. So, conditional distribution. Sorry about that. Conditional distribution of gender. All right. So what are we trying to break down? What are we trying to break down in here? The distribution of what? What are we trying to break down? The distribution of what?
Glass wearers?
Gender. Well, yeah, gender. It's written together. It's right here, right? We're distribution of gender. So we're trying to break down gender, which means males and females. So my answer should say blank males, blank females. Okay? My who is what? It is not. My who is smaller. Who?
Oh, the people that wear the glasses?
Correct. And we need to be more specific.
The 8 people that wear glasses?
There's more than 8 people. What is it?
8 females that wear glasses.
No, how many students wear glasses?
12.
12. It's that. Remember that it's that marginal one. So it's the 12 students who wear glasses. So my what is still gender, which is, and I'm going to break down into males and females. So I'm going to word this one opposite. Okay, so I'm going to talk about the who first. I did in the previous examples. I did what and then the who, but I want to show you that you can say who and then the what. So I'm going to start with the who. Of the 12 students, AP students, 12 students who wear glasses. Okay, so that's the who. The distribution, the conditional distribution of gender, that's my what, is what? So of those glass wearers, how many are males? How many are females?
That's 12.
How many males of those glass wearers?
12. Store.
This is
4
the word.
males and 8 females.
There we go. Yeah, we're only focusing on, we only live in the world of glass wearers. We only care here. So really, all this information, we don't even care about. All we care about is right here. We only care about the world of people who wear glasses. So for this problem, all I'm caring about is there. My whole world and my whole focus for this problem is right there on that. I'm having a little fun here, I guess. Is right here. So I have 12 glass wearers, 8 females and 4 males. Of the 12 glass wearers in the class, 8 are females and 4 are males. Don't worry, that's going to go away. See, it went away. Is 8 males, oh, wait, was it male? 8 females. 8 females and 4, can't even spell today, and 4 males. That is a perfect answer. So when I talk about conditional distribution, ask yourself the distribution of what? Okay? That what is what you need to break down. Now, if the problem states the following, describe the conditional distribution of vision among for the gender. Now, this one's a little bit trickier. So, it's still a conditional distribution. And what we have to do here, so we need to break down, what are we breaking down? What are we going to break down? What is the what? What is the variable that we're focusing on breaking down? The distribution of what? Read the sentence. What are we breaking down? The distribution of vision. Yeah, it's right there in one sentence. Distribution of vision. Okay? So don't overthink that part and see it's connected in one word, in one part of the sentence. We're looking at the distribution of gender, which means my answer should say something like blank glasses. Let me do a different color. My answer should say something like blank glasses, blank contacts, and blank neither. Okay, so that's how I need to break it down. I need to break down the vision options. But wait a minute, it just says for gender. Okay, so when it does this, the previous one I could have said for males. I could have just said for the males and left it at that. And you only have to break down males. But now I said gender, which means you need to do this for the males. And guess what? You need to do it for the
Females.
and the females. So you have to, and your answer is actually going to be 2 sentences. So blank glasses, blank contacts, not contacts, contacts, and blank neither. But we still must have to talk about the who, the what, and what those answers are. So yes, this problem requires you to write 2 sentences, not just one. Because there's 2 genders, and so for each gender, I want you to break down the distribution of vision. So with that, how many males are there? Of the
There's no need to keep calling me Mr. Sterling. I'm here now.
Okay. You can also text. I made Mr. Sterling a co-host, so if you do ever need to contact him, you can also type it here in chat for him. Just give you a heads up to everybody. So let's break down males. How many males are there? Of the 8 males, now I'm gonna note this. Of the 8 males, now in the previous problems I wrote down, you know, come on, the distribution of vision. But I want to note something, that you technically don't need to write the distribution of vision, because when you talk about glasses, contacts, and neither, what are you referring to? Vision. All right. How many of the 8 males? Of the 8 males, all right, which means we're only looking in this one right here. So ignore the females, ignore the turtles. I like turtles still more. Ignore the totals. We're only looking right here. So of the 8 males, how many wear glasses? I guess I should have said we're ignoring this one, and we're ignoring this one.
4.
4 wear glasses. How many wear contacts?
0.
Good. And neither? Perfect. 404. Of the, how many females? How many females? Of the 14 females, the distribution of vision, and I guess I should have, to be a little bit more proper English, I could have said is, right? How many wear glasses? How many wear glasses? 8. Contacts? 1. Neither.
5.
Boom. Okay. Now, building off of that, I'm going to ask what looks like the same question. Describe, and I'm going to add just one word. Describe the relative conditional distribution of gender amongst gender. Just sometimes they use that type of vocabulary, so I want to try to show you different types of wording. We have to expand our vocabulary and not say, well, you said of, or you gave the who first and the second was the what, and they asked it in the other way. And we have to understand it's still the same thing. And it takes practice of that. Now, what is the only thing I changed in this question? Relative. That's the only piece of information that's different. Which means that my answers, my distribution breakdown, just as a review, relative means that the distribution, the breakdown means that we're going to break down with what? We're going to break them down using what? Percentages. Perfect. Everything else stays the same. How many sentences am I going to have to write? 2, because I have to talk about males and I have to talk about females. Okay? Most of the sentence will be the same. So we can even copy down basically everything except for what is blank, right? So everything is almost a carbon copy of the 8 males. The distribution of vision is blank glasses, blank contacts, and blank neither. It doesn't matter if I'm talking about just frequencies or relative frequencies for my distributions. The sentence is still the same. Now, okay. So in the previous one I wrote 4, but that's not a percentage. What is my answer? How am I going to do this one? Before there was 4 glasses, but that's for the males. There was 4 glasses. So how do I turn that into a percentage?
Isn't it 0.04
No,
or 0.4?
no. What must your percentages here? Let me ask this question. What must your percentages add up to in the end?
100%.
100%. That usually will key to you. What is that?
I'm gonna say like divide 4 by and then
Yep.
times 100.
Correct. But what is that? What is that something?
4 divided by 8.
4 divided by 8. So we're going to take the 4, we're going to divide it by 8, and we're going to multiply it by 100%. And 0 divided by 4 times 100%. And 1 divided by 4, or actually there was 4 again, times 100%. So instead of saying 4 were glasses, we're going to say what percent? What is that? That's a simple math. I think we can all do that. What is it?
50%.
50%. Good. 0%. I'm going to finish these ones out because I think they're relatively easy. And 50% neither. All right. We got to go talk about females. So of the 14 females, the distribution of vision, you can say of, you can say for, sometimes, for the, same thing, of vision is blank glasses, blank contacts, and blank neither. And basically, you're just going to take your outcomes. Instead of 8 glasses, we're going to take 8 and we're going to divide it by how many females? So we're going to do 8 divided by
13.
And 8 divided by 14 times 100%, even though I don't want to always show times 100%, but it is times 100%. So 8 divided by 14 gives, and this is where we have to pull out our calculator. I mean, we just need a basic calculator. If you want to go to Desmos.com and use their calculator, if you have your own calculator at home, you just need a basic 4-function calculator right now. Nothing fancy yet. What do I get? Your phone.
57%, I think.
About 57%, okay? And if I do, the next one would be what? 1 divided by 14? What does that give me? And the last one is it 5 divided by 14? One divided by 4, so 8 divided by 14 is about 57%, yes. 1 divided by 14 gives me, I'm just using my phone, which gives me about 7%. 5 divided by 14 gives me around 36%. And it's like 35.7, but I need to realize that I need to round that up. Okay. So all I do is I put those numbers into here. So 57. Now and this is why it's also very important to say 14 females, because 57%. Is that a lot or a little? Well, it's a lot. It's more than half. But 14% out of 14 is not as amazing or cool as 57% out of like 1,000. That would be something like it was like, because you might say, hey, if one female didn't wear glasses, the percentages would take a huge swing. So understand that 14, which we'll understand in this course, becomes very important later on. Okay. Next question. Now, you've basically done everything you've really done. You've done all the hard work. And I think we have, what, 7 minutes left?
Yep.
All right. So I'm going to present you with a different table now. I'm going to give you the table. So here's a new example, and I'm going to give you the table. This is just straight up students. We will say that there are 17 students, and we'll talk about clothing, and they can wear jeans, they can wear a dress, or they can wear some other, and we'll still use the same breakdown on the other side. We'll talk about males and females. I'm going to give you this. We'll just take this as the problem. Okay, and I have 2, 0, 3, 5, 9, 1, 2, 12, 11, 1, 5, 17. Now, I do want to point out something. If I divide everything out, okay, sometimes this is called, a regular two-way table. I can also do something like row percentages. So and I want to point out that if I in place of right here, the 2, and I did 2 divided by 5, I'd get like 40% if I did 2 divided by 5. I'd get 0% here, I'd get 60% here, and I'd get 100% here. Okay? If I divided 9 by 12, I get 75%. I get 8%, I get 17%, which adds up to 100% over here. Now, these tables are sometimes given to you with those numbers in purples, and I know I wrote them a little bit smaller, but sometimes you're given those ones. We would refer to these as row percentages, okay? And so what these would do is these would break down clothing. It breaks down clothing for each of the genders. So this, if I had asked you the question, what is the marginal distribution of clothing for males? We would be like, ooh, it's going to be 40% jeans, 0% dress, 60% other, if it was relative frequency. So I do want to point that out, and we know it's rows because the rows add up, the row percentages add up to 100%. All right? There's a homework question I just want to point out. For our last question that we're doing today, I want you to focus on the black part. That's the last questions we're going to be doing. I want to ask you this. What percent of students are males? There's my first question. What percent of students are males? Show your work. You must show work. You must show the work, which means I need to see the fraction that you're dividing. All right, so can anybody tell me how to find the percent of males of all the students? So who is my data about? Who is the students of talk? Who is this question talking about? No.
The 17 students.
Yeah. This is the who of the students. What am I asking about? The what. And basically, you always take the what, you take the number of the what, and divided by the number of the who. So, how many males are there in the class? How many males? 5. Divided by how many students?
17.
Perfect. 5 divided by 17. Actually, you can give me this. This would be full credit. I'll accept 5 divided by 17 as the answer. I will accept 0.714 as an answer. I will accept 71.4% as the answer. And similarly, I would probably accept 71% as well. But you must show that fraction, 5 over 17. And for our purposes, you can stop there. 2 more questions. I know we have 1 more minute. I'll be able to finish. Example. What percent of males what percent of jean wearers are male? Okay. Who am I talking about? Who am I talking about?
On the students?
No,
Oh,
I am not talking about the students. Who am I referring to in this statement? Jean wearers. How many jean wearers are there? What? How many jean? 11. My numerator better be less than it. So how many males are jean wearers?
2.
And that's my answer. And if I flipped it and I said, how many males are jean wearers? What percent of males are jean wearers? If I flipped that question, the denominator would have been 5 and the numerator would have been 2. Oftentimes people say, isn't that the same question? It's not. You'll get some practice in tonight. If you have any additional questions about the homework, I'm available in office hours. It's 10:50. I know you have to make your way to the other class. Thank you for your participation today. Have a good day.